Thank you for the kind introduction, and thank you all for being here. I am excited to share some of the work that I've been doing with my colleagues on emotion regulation and stress and their relationship to suicide risk. So emotion regulation refers to a range of processes that help us manage our feelings. It typically involves either upregulating or downregulating our emotions to match the situation that we're in. And we do this by shifting our thoughts and behaviors, sometimes consciously and effortfully, sometimes unconsciously and automatically. To give you an example, some people recommend for public speaking that you downregulate your anxiety by imagining the audience in their undergarments. I'm not sure who this works for, but this is a good example of reframing a stressful situation to make it less threatening as an emotion regulation strategy. Our bodies also help us to manage stress. So for example, the adrenaline rush I might be feeling helps me to focus on the task of presenting. So emotion regulation is crucial to adjusting to ever-changing environments and daily demands, managing relationships, achieving future goals. We regulate all of the time, but particularly in those difficult, stressful moments. Individuals with depression who are at high risk for suicidal behavior, they often report difficulty regulating in their daily lives. Compared to healthy individuals, they report feeling more overwhelmed by their emotions, and they report having less access to tools and strategies to help them effectively deal with intense negative emotion. This seems particularly worrisome when we consider that stressful events are common proximal triggers for a suicide attempt. Suicide attempts are often preceded by a very stressful life event. So we might conclude that there's something in the way that people at risk for suicide regulate that may put them at increased risk. But specifically, what sort of issue with emotion regulation might lead to heightened suicide risk remains unclear, and this is the gap in research that we're aiming to address. Specifically, we want to understand more about how depressed individuals respond to stress in their daily lives. This is difficult to capture when you give people a one-time questionnaire, retrospective questionnaire, which is the most typical in emotion research. Instead, we had individuals use their phones to give us a detailed report on their daily experiences. David presented briefly on this, and I'm going to go into a little bit of more detail. So we had participants report on occurrences of stress, on their emotions, suicidal thoughts, and self-harm behaviors for 7 days in a row, 6 times a day. And this provides a very granular picture of their everyday experiences because they're essentially reporting on them as they're happening in their homes with their own cell phones rather than in a lab. And we call this method of collecting real-world data ecological momentary assessment, or EMA. To give you a sense for what EMA data can show us, here is a graph of depressed individuals' suicidal ideation over the course of a week. And each row here represents a single participant. Each data point represents the occurrence of suicidal ideation. The severity of their ideation is indicated by the size of the data point. The more severe, the larger. In addition, the color of the data point indicates whether participants reported something stressful occurring. So the pink circles indicate that a stressful event happened. The blue indicate that no stressful event was reported. And what you can see is that suicidal ideation tends to fluctuate in tandem with the occurrence of stress, so that suicidal thoughts are more severe when they occur together with a stressor. So I'm going to review a couple of studies that we've conducted using EMA, and I believe these studies demonstrate how this technique can be leveraged to understand emotion regulation difficulties that increase risk for suicide. One advantage of EMA data is that it can capture both the causes and the consequences of suicidal ideation and its relationship to other behaviors. I'll illustrate with a study here that we conducted in a sample of women with borderline personality disorder, or BPD. BPD is characterized by difficulty regulating emotion, by high risk of suicide attempts, and high rates of non-suicidal self-injury, or NSSI. NSSI is more colloquially referred to as self-harm. Self-harm is when individuals harm themselves, but without the intention of ending their life, generally more superficially than suicidal behavior. And people engage in self-harm for many reasons, but frequently they report doing so to regulate intense negative emotion, including suicidal urges. In other words, people use self-harm as a way to cope with and manage suicidal thoughts. But the use of self-harm to regulate suicidal thoughts had not been studied quantitatively before. Here, we used EMA data to identify instances of self-harm in the sample over the course of a week, and we looked at the period immediately preceding the self-harm and the period immediately, immediately following self-harm. And what we found is that suicidal ideation is higher just before that instance of self-harm and significantly lower following the self-harm. The reason this relationship is really important to quantify is because the use of self-harm to manage suicidal urges has important implications for suicide risk, particularly in this very vulnerable sample. Our data show that in the short term, self-harm is quite effective at lowering suicidal ideation. It lowers it about 1.8 units, to be precise. But the literature showed that repeated self-harm heightens risk of suicide considerably in the long term. Self-harm is one of the most robust predictors of future suicide attempts. And this might be because it lowers the threshold for engagement in more serious and potentially fatal self-harming behaviors in the future. We took the EMA method further by combining it with functional MRI, or fMRI, in a unique way. fMRI involves using an MRI scanner with a big magnet inside to identify localized brain activity that's associated with a particular mental process. In this case, we wanted to understand how depressed people regulate by examining what their brains look like while doing so. To give you a sense for what fMRI produces, you might imagine an image of the brain made up of a tiny little Lego blocks, with each block representing a small 3D cube of brain tissue. And when you think, feel, or do something, different Lego blocks light up in different patterns. To derive the pattern that corresponds to emotion regulation, we used a machine learning technique applied to the fMRI data to identify a neural signature for emotion regulation. The neural signature reflects how the brain lights up, so to speak, during emotion regulation. So in order to see what the brain looks like during regulation, we had participants regulate. And we did that. We had healthy and depressed participants view upsetting images while in the scanner. And for some of the images, we asked participants to view them while using a cognitive regulation technique called reappraisal. And briefly, reappraisal means changing the meaning of something in order to feel better about it. And it's one of the more effective emotion regulation techniques. We then trained an algorithm on the fMRI data. This is the machine learning element, to identify a pattern in the brain that indicates when participants are using reappraisal as opposed to when they're simply viewing the images without regulating. And this is how we created that neural signature for emotion regulation. We then use this neural signature as a tool to get a deeper understanding of how depressed people regulate. To do this, we had depressed participants complete a task in which they recalled their own upsetting memories in the scanner. And they recalled their memories under two conditions. One, in an unstructured way without any direction, and two, using a regulation strategy similar to reappraisal. The unstructured condition allows us to understand how do participants regulate when they're not told to do anything. In other words, what is their spontaneous tendency? What do they do naturally? And the regulation condition allows us to assess their capacity for regulation. When they're told to regulate, how well are they able to do it? And we applied the neural signature for emotion regulation to each of these two conditions, and then we used that data to predict how depressed participants cope with stress in their daily lives, as assessed with the EMA data that I mentioned earlier. And what we found is that depressed participants who regulate spontaneously on their own, they react to stress with more suicidal thoughts, and that's the orange line that you see upward. This might not be what you would expect, that a greater tendency to regulate would be associated with more severe suicidal ideation. But when we look at how depressed people regulate compared to healthy individuals, we see that healthy folks regulate the least when they're exposed to their own upsetting memories, while depressed individuals regulate more, much more. And interestingly, depressed individuals with a prior suicide attempt, they regulate the most when they're presented with their upsetting memories. And we might conclude from this that depressed people, and particularly those at greater risk for suicide, may have a low tolerance for negative emotional material. They might attempt to deal with distressing material by overregulating and dampening their emotional response, even when the stakes are relatively low. In other words, people who are vulnerable to suicidal behavior might be more reactive to negative emotional material in general and attempt to regulate it harder, and this reactivity may also be why they experience greater suicidal ideation during stressful events. We also found that depressed folks who regulate better when they're instructed to regulate, you might say in a context-appropriate way, they experience less negative emotion during stressors, meaning that their intact capacity to regulate may translate to actual more effective regulation in real-world situations. I'm going to end with this last study of ours where we aim to identify a biological variable that might contribute to heightened suicide risk during experiences of stress. Here, sorry, excuse my cold. Here we used PET imaging. You're going to hear more about that from Betsy, but briefly, we used PET imaging to derive a measure of inflammation in the brain, neuroinflammation. Why neuroinflammation? Neuroinflammation is associated with depression. It can result from mental illness and potentially from life stress, but it might also leave the brain in a sensitized state, making people more likely to react to stress with more severe symptoms, such as with suicidal thoughts, putting them at greater risk in the future. To test this, we measured a protein in the brain called TSPO, which is thought to be an indicator of inflammation in the brain. And again, we looked at this biological marker of neuroinflammation together with EMA to examine how neuroinflammation might predict responses to everyday stress in individuals with depression. What we found is that, indeed, greater neuroinflammation is associated with greater suicide risk, but only in the context of a stressor, meaning that neuroinflammation may be uniquely related to the risk of suicidal thoughts emerging in the context of stressful events. We also found that neuroinflammation was associated with greater negative mood symptoms across that week-long EMA period, but again, also specifically and even more strongly in the context of stress. This is a really powerful finding because here we have this lab-based biomarker that could potentially indicate who amongst depressed individuals are vulnerable to stress-related increases in suicide risk and in negative mood symptoms. To summarize, what we've seen is that our EMA data can provide really important insights into how suicide risk unfolds in daily life. EMA also allows us to make meaning of our biomarkers associated with depression and understand how they might be related to the way suicide risk emerges in real-world circumstances. Ultimately, our goal is to predict suicide risk in real time and prevent unnecessary deaths. And we're continuing to use EMA with other exciting neuroimaging tools. For example, I'm currently working on a grant project that will measure certain neurotransmitter systems, certain chemicals in the brain that are relevant to depression. And pairing these data with EMA can help us understand the downstream effects of these neurochemicals on suicide risk. So thank you for your attention, and I want to briefly thank my mentor, Dr. Mann, and my colleagues at Area Mind, and our funders that make this work possible. And I'm happy to take questions.